Ever wondered why some AI models follow your instructions perfectly while others stumble? The answer lies in their training, specifically how they learn from examples. Today, we're diving into a groundbreaking study that's redefining how we train language models to understand and execute complex tasks. Let's start with the basics. Language models are like students learning to write essays. They begin with pre-training, absorbing vast amounts of text to predict the next word. But when asked to follow specific instructions, like explain quantum physics in simple terms, they often falter. Why? Because pre-training focuses on pattern recognition, not instruction comprehension. This is where instruction tuning comes in. Think of it as teaching a student with example essays that include clear instructions and correct answers. By fine-tuning on these examples, the model learns to follow directions. But here's the catch. Most existing methods only optimize the response part of the example, ignoring the prompt entirely. Researchers asked, what if we gave the prompt some attention too? They developed weighted instruction tuning, WIT, a method that assigns a small but meaningful weight to the prompt's loss, a measure of how wrong the model is, while prioritizing the response. Imagine adjusting the volume of a song, giving the lyrics prompt a bit more attention so the melody response makes sense. By balancing these weights, the model learns to grasp the context of the instruction, not just generate a correct answer. Their experiments across 5 models and multiple datasets revealed stunning results. WIT improved performance by up to 6.5% on tasks requiring reasoning and complex instructions. Even more impressive, these models adapted better to new tasks and subtle prompt changes, like a student who can tackle any essay topic, not just practiced ones. The takeaway: training matters as much as data. By rethinking how we weight prompts and responses, we're making models more robust and generalizable. So what's next? This research opens doors to smarter training methods that could revolutionize AI's ability to understand and interact with us. For deeper insights, check the open source code and stay tuned for more explorations into AI's evolving landscape. Thanks for watching. If you enjoyed this, hit subscribe and let me know what you'd like to see next. Until then, keep questioning, keep learning, and remember, AI's future is in our hands. But here's another twist. The balance between prompt tokens and response tokens also matters. Imagine teaching a robot to cook. Too many ingredients, prompt tokens, and it gets confused. Too few, and it can't adapt. Researchers found that balancing these inputs boosts performance by nearly 8%, a game changer in AI. To visualize this, they used heatmaps, colorful grids showing how tweaking prompt and response lengths affects performance. For example, Llama 3.8b saw a massive jump in scores, while Gemma 2.2b showed more modest gains. It's like giving different chefs the same recipe. Some thrive with a nudge, others need a full overhaul. The key lies in loss functions. Traditional methods ignore prompt loss, but WIT assigns it a small weight. This ensures the model understands the context of the instruction, not just the output. For instance, on the MMLU benchmark, Llama 3.8b's score doubled with WIT. Meanwhile, instruction tuning, IT, boosted AlpacaEval scores by over 200% for some models. But there's no one-size-fits-all. Larger models like Llama 3.8b benefit from bold adjustments, while smaller ones like Gemma 2.2b require precision. It's like cooking. A big pot needs more spices, but a small dish demands exact measurements. So what does this mean? AI isn't a static tool. It's a puzzle where each model and task needs its own solution. The next time you interact with AI, remember, these heat maps and tuning techniques are the secret sauce behind the scenes. Stay curious, and let's keep exploring the science behind the magic.